My name is Daveena Ashwini.
Hello, my name is Semenyih. We are from Sekolah, Kebangsaan, Jalan, Semenyih in Kajang.
We are representing our school in the 2020 National Robotics Competition under the Primary Open category.
The theme for this year is Climate Squad. We need to invent robotic solutions to reduce climate change.
Our project for this competition is to create a robotic solution to manufacture things locally so that we can reduce long-distance transportation of manufactured goods.
To complete the project, we had to do a lot of research and brainstorm many different ideas. You can read all about our work in the report that we wrote.
After all our research, we decided to focus on 5 main areas for our project: local manufacturing, microfactories, industrial 3D printing, recycling, and renewable energy. We built a model of a microfactory that will simulate the manufacturing of 3D printed footwear such as shoes and sandals. We named our project Green Footprints.
A lot of footwear is being made in countries like China, Thailand, and Indonesia. Then they are transported to buyers across the world, which causes a lot of pollution. Some 3D printed technology is already being used by shoe companies like Adidas and Reebok.
These industrial 3D printing microfactories can be located in major cities closer to customers, which can help avoid long-distance transportation and reduce pollution. Our microfactory will also recycle old 3D printed items to make 3D filaments. These will be mixed with new filaments to make the footwear. This will reduce the amount of raw material used and will also reduce waste. All of these factors will be good for the environment and help minimize the effects of climate change.
Our microfactory will always be fully automated and powered by renewable energy from solar, wind, and battery storage. This will reduce pollution caused by electricity generation.
Now, on to some technical information. We decided to use the LEGO Education Spike Prime robotics set to build our model. We chose Spike Prime because we were excited to try a new robotic set and also because we like coding using Scratch. We also use pieces from other LEGO sets like Mindstorms, Power Functions, and Classic to complete our model.
For our main model, we used 2 large motors, 2 medium motors, and 2 color sensors connected to Spike Prime hub. We also used a battery box, a small motor, and LED lights to build the renewable energy plant.
I'm sure you are all excited to learn about our model in more detail. So here it is. There are 3 main processes in our microfactory: the recycling process, the new filaments process, and the new footwear process.
The recycling machine is here. It will recycle all 3D printed items into filaments that can be reused to make the footwear. It is operated by 1 large motor that will move the conveyor belt.
This is the new 3D filament injector. It is operated by 1 medium motor that will push the 3D filament canisters down into a ramp, into a tank. There is also a color sensor that detects when the injector has moved forward and triggers the recycling conveyor to move.
Next, we have the industrial 3D printer, which is this section. It is operated by a medium motor. This will simulate the 3D printing process to make new shoes. It will push out the new shoes onto the conveyor belt. This will usually take some time for actual 3D printing, but we will speed the process for our simulation.
The final part of our microfactory is the completed footwear conveyor, which is this section. It is operated by 1 large motor, which will move the conveyor belt. There is also a color sensor here that will detect the completed footwear when the completed footwear has reached the end of the belt. This will trigger the new filament injector and restart the whole process again.
Now, we will do a short demonstration to show how our microfactory model works.
First, a new 3D filament is injected into a tank.
Then, some recycled filaments are loaded into a tank.
The 3D printer will produce a new set of footwear.
The sensor detects the completed item and starts the whole process again. I hope you enjoyed the demonstration. Now we will tell you about our renewable energy plant that supplies clean electricity to the microfactory.
Thanks, Wong. The renewable energy plant is located next to the microfactory. Here are the solar panels, and this is the wind turbine. We also have battery storage that can provide electricity when wind and sunlight are not available. You can see the wind turbine rotate and the LED lights light up when I switch on the model.
Thanks, Daveena. Before we complete our presentation, let's do another demonstration of our robotic microfactory. That brings us to the end of our presentation. To summarize, we built a robotic model of a local microfactory that will manufacture footwear using 3D printing technology. If we have many of these microfactories located near to customers, it will help the climate because of 4 main factors.
It will reduce waste by using recycled 3D printed items. It will use less resources by being fully automated, more efficient, and remotely operated from a central location. It will reduce pollution caused by long-distance transportation of manufactured goods, and it will reduce pollution caused by the electricity generation by using its own renewable energy power plant.
We hope you enjoyed learning about our project as much as we enjoyed working on it. We had a lot of fun, learned a lot of new things, and did the best we could.
We also had so many other ideas to make our model even better. Unfortunately, we did not have enough time to implement them, but that you can read about them in our report.
She is Daveena.
He is Wong.
And we are the Climate Squad from Sekolah Kebangsaan Jalan Semenyih 2 in Kajang. Thank you for watching. Take care and stay safe.